And I want to welcome everyone to today's webinar on the top 10 requirements you should know, in particular for the 2018 International Energy Conservation Code for the commercial lighting section. So before we begin, I do want to make a few notes. Today's webinar is being recorded. We do anticipate the webinar taking approximately 1 hour. If you do have questions, feel free to enter those into the question and answer box. You should be able to find that, I believe, by hovering towards the top or bottom of your screen to reveal the control panel. A PDF and the recording of today's presentation will be posted to the Smart Energy Design Assistance Center website following today's presentation. We do have continuing education units available for AIA as well as IECC credits, and certificates will be provided following the webinar for any other CEUs that may be self-reported and appropriate for the topic. When the certificates are issued, there will also be a link to a survey about today's webinar, so we would ask that you please do fill that out. That helps us as we develop more webinars into the future. So with that, did note that today we do have ICC as well as AIA credits. So if you do have a need for those, when these certificates are sent out, we will ask to be provided your member numbers so we can report those directly for you. So a little bit about our objectives today. Obviously, we're going to be covering the commercial lighting provisions, looking at the Illinois Energy Conservation Code, which has now moved from the 2015 to the 2018 International Energy Conservation Code as its reference document. We'll cover the 10 most important topics, as well as a little understanding as far as compliance with the code. So a little bit of background about who we are. We are part of the University of Illinois here at Urbana-Champaign, and our primary mission is to reduce the energy footprint of Illinois, both public and private sector, and so the Energy Code is one method to accomplish that. So our training today is being sponsored in part by the Illinois State Energy Office, which is part of the Illinois Environmental Protection Agency, or IEPA. And we do want to thank them for their assistance with providing that for today's webinar. Something we do have that's available to any projects related to the state of Illinois, and that is our technical support line. Have an email address, energycode@cdac.org, along with an 800 number. We do have several online resources available at our website, which we'll talk further about as we go further into this presentation. Some of those include archives of our past workshops and webinars. That is also where we announce future workshops and webinars as they become available and scheduled. We also have several online and on-demand training modules. And we just released 2 new ones on ResCheck and ComCheck. These take approximately an hour to an hour and a half to complete. So do encourage people to take advantage of those. They are written sort of for beginners and people that are not really familiar with the code. So this can be good for perhaps building owners and occupants. If they have questions, that this is a opportunity for them to learn a little bit more about it. So, as far as the effective date, when Illinois moved from the 2015 to the 2018 Energy Code, it was effective across the state of Illinois for permits issued beginning July 1st of this year, and for the city of Chicago beginning June 1st of this year. So here we are about 6 months into the new code for the year. One of the big changes that we saw as part of this transition was state-funded facilities. Previously were required to use ASHRAE 90.1. They now have the same options that everyone else in the state had to either follow the International Energy Conservation Code or ASHRAE 90.1. So that was some nice flexibility that was added this year. Here we have some links to some various reference documents. These are also available under our helpful links area at cdac.org. The first is the International Code Council and the IECC 2018 reference document. The second is the Illinois specific amendments to that document. And third is for the City of Chicago amendments. We will note that the ICC is generous in that they provide free access to all of their codes for viewing online. And these are actually very useful in that the search function is very robust for that. So today is part of a series of webinars. We've had 2 previously. The next one will be in January, looking at commercial HVAC. And then we have another one in May covering ResCheck and ComCheck. So this is also done as part of a series of top 40 workshops. That we have 4 of these coming up here in the spring, 2 in March and 2 in April presently scheduled. I believe there will be 1 or possibly 2 more scheduled for the springtime as well. So be looking forward to those. Again, if you've signed up for our newsletter, information will be released in that, as well as posted to our website as those become available. So just a quick view of our top 10 that we're going to be covering today. So looking at the various controls, lighting power, as well as some commissioning. So with that, I'm going to turn it over to Sean to continue in. Thank you.
All right, so the first topic we're going to cover is occupant sensing controls. This is occupancy sensors, vacancy sensors, and other devices that can be used to determine whether a space is occupied or not. So we've got some examples here on screen, a time clock, a couple of different occupancy sensor types, and a Luminaire level occupancy sensor around there. So new to the 2018 IECC, open office plans were added to the list of areas that are required to have occupant sensing controls. So the first thing we're going to cover, the Energy Code breaks out 3 specific occupant sensing control areas, warehouses, open plan offices, and then all other areas. So the first section we're going to look at here are warehouses. In warehouse areas, open areas and aisleways must be controlled independently from each other. Lighting must be reduced by at least 50% when those spaces are unoccupied. And controls for individual aisleways should be independent. So if someone's walking in one aisleway, you're not turning on lights a couple aisleways over, only where that lighting is needed. Moving on to the open office plan section of the lighting occupant sensor controls. For open plan offices greater than 300 square feet, you have individual control zones in an open plan limited to 600 square feet. And within those zones, lighting must be reduced by at least 80% in a reasonably uniform manner within 20 minutes of that zone being unoccupied. And all general space lighting should turn off within 20 minutes of all zones being unoccupied. So lighting should be entirely off within the space. And daylight responsive controls may not override the occupant sensing. That way, if you got a daylight sensor in the space, it's not turning lights on in a space that's unoccupied. Your occupancy sensor should override the daylight controls, not the other way around. So one of the ways to achieve this requirement, where lighting within individual zones and all zones must turn off within 20 minutes, is if you have individual zones that just turn off entirely instead of going down to 80%, that will meet the point number 3 here, where all lighting must turn off within 20 minutes of unoccupied space, since all lighting will already be off. The other option is to link all your occupancy sensors together so that there's a signal that says all sensors are off, thus all lighting can now be turned off entirely instead of going to that 80% minimum per zone. Moving on to all other areas where occupant sensing controls are required. Again, at 20 minutes of space being unoccupied, spaces should turn off lighting automatically. Lighting can be manual on or can be auto on. If it's auto on, it cannot turn on to more than 50% power, except in instances of safety, security, public corridors. So there are some specific exceptions called out in the code there. And also, occupancy sensors should incorporate a manual control to allow occupants to turn the lights off. We had an example of a library that put in occupant sensors everywhere, but no light switches, so there was no manual off override. And they had some meeting rooms with digital wall displays that when people were trying to use those, they couldn't see them because they couldn't turn off the lights overhead, and it made the screens difficult to view. So there are some design issues there, and that's why that manual off override is in place. Moving on to time switch controls. In spaces that are not provided with occupant sensing controls, or not required to have them in the code, time switch controls are required. Again, there are some specific exceptions listed: patient care, safety and security spaces, shops and laboratories, anywhere where there's going to be some kind of danger from the space going dark while an occupant is in that space, if lighting should automatically turn off. Those areas are exempt from this requirement. Another thing we'd like to note is that while if you've got spaces that are required to have time switch controls, you can optionally use an occupancy sensor instead of a time switch control. You cannot go the other way, where if you're required to have an occupancy sensor, you could not install a time switch control instead. You could, however, have occupancy sensing and time switch together in a space that's required to have occupancy sensors. But that is a one-way trade-off with time switches. Required controls for time switch must have a minimum 7-day clock capable of 7 different day types. Should have the ability to do holiday scheduling, so you can skip a schedule for 24 hours. You're not turning on lights, like say we've got Christmas coming up and your office building is going to be closed. You don't want to be turning lights on when no one's there. The program should have a backup of at least 10 hours, a battery backup of some sort. And it should include an override switch with a maximum manual override of 2 hours. And individual switches should not cover more than 5,000 square feet. There are some exceptions for large mall type areas, things like that. As part of the time switch controls, there are this section requirement for light reduction controls. This is stating that lighting in a space should have the ability for occupants to reduce their lighting by 50% in a reasonably uniform pattern. And there are some examples given in the code, either at a luminaire level or individual lamp level within the luminaires, some way to evenly reduce that lighting by 50%. There are some exceptions to this requirement. Spaces with one luminaire rated at less than 100 watts, spaces with less than 0.6 of a watt per square foot, corridors, lobbies, mechanical rooms, and daylight zones with responsive controls. So again, point 3 there is kind of calling out safety and security areas. You don't want lights necessarily dimming down in an area where you've got potential safety issues. Moving on to daylight responsive controls. One of the things we like to call out here first, this is kind of a rare situation where we like to call out the exception to the rule ahead of time. But anywhere where you can not put in daylight sensing controls saves you on commissioning, saves you on installed equipment, upfront labor costs and material costs. So we like to highlight here that if your daylight zones can have the budgeted lighting power reduced by 40%, then you do not have to install those daylighting controls. And that 40% is an area weighted average of daylit zones to the adjusted lighting power for the entire space. So here we've got a couple of examples of how that might look. Say in a 200,000 square foot office, you've got 100,000 square foot of daylit zone. If you can reduce the connected lighting power in that space from 158,000 watts down to 126,400 watts, that's a 20% reduction. That's what that area weighted average looks like. So you've got that 100,000 square feet reduced by that 40% divided by the 200,000 square feet. The next example, say that daylit zone is a little bit smaller for the same square footage down to 50,000 square feet. Now you only need a 10% reduction in wattage for that space instead of a 20%. So that's how that area weighting average works for the daylighting control exception. When you do install daylighting controls, they are required in spaces with greater than 150 watts of general lighting in a side lit or top lit zone. Again, there are exceptions for specific spaces, healthcare facilities with direct patient care, lighting for specific applications, or side lit zones on the first floor in a mercantile or food and drink type space. Control functions required for those daylighting controls. Top lit and side lit zones should be controlled separately. The code does allow for about 150 watts of overlap because we realize that if you got a skylight near a window, those daylit zones are going to overlap a little bit, so there is allowance for that within the code. Those daylight controls must be able to be calibrated within the space so that someone who's doing the calibration can actually see what's going on with the equipment. You're not able to go into a back room somewhere and make adjustments where you can't see what the lighting's actually doing in the space. The calibration mechanism must be readily accessible to building staff, not necessarily the occupants within the space, but maintenance staff. So if you've got a controller, some kind of wireless device that does that calibration, they can lock that away in a room and get it out when calibration is necessary. But again, must be readily accessible. In offices, classrooms, laboratories, library reading areas, places with high contrast requirements and continuous where you wouldn't necessarily want lighting to flicker, must be able to dim continuously down to at least 15%. And below that, then they would just shut off if daylighting exceeds the lighting requirements. Lighting must be configured to turn lights completely off when adequate daylight is present. So even in spaces that have step dimming, again, lighting must be able to turn off completely. In side lit zones on different cardinal directions, so you've got a corner space, if you've got a long wall or something like that, those side lit zones would have to be independently controlled from each other. The exception being a small corner office or something where, say you've only got a couple of fixtures, the exception specifies less than 150 watts within the space, then you can have side-lit zones controlled together. But it's say like an open office plan or something like that, a lobby area that's a large space, then your different oriented walls would have to be controlled independently. So how do you know what is the side-lit zone within your buildings? The codebook has these handy diagrams that explain how to determine what your side-lit zones are, and there's another diagram for top-lit zones. So you take your window floor to top of window height and flop that down into the building, and that's the depth of your daylit zone. And then the width of the window plus 2 feet on either side is the width of your daylit zone. Again, some specific requirements. The area of fenestration has to be greater than 24 square feet, and your visible transmittance has to be greater than 20%. So if you've got excessively dimmed windows, you're not going to get a lot of daylight through them, then you would not have a daylit zone in that space. Or if you've got a small like transom window or something like that that's not going to admit a lot of light, again, you're not going to have a very large daylit zone, not worth controlling. So the code does call those out as exceptions. This is an example of what daylit zones might look like drawn up on a floor plan. So here you can see they've shaded the regions that are the side lit zones for the space. A lot of these you can see have a couple of fixtures in them. If those are 4 lamp, then those individual zones would have to be controlled. But some of those spaces have individual fixtures. Those would not require daylight controls within them if you've only got a single lamp. We would also recommend for designers and plan developers that as you're making these drawings, consider making a lighting plan with the zones highlighted in this manner and a plan without. That way copies of these plans can be made where over time these shaded zones aren't going to darken and cover up what's hidden underneath the plans. Moving on to top lit zones. Again, there's a handy diagram within the codebook that explains how to determine where your top lit daylit zone is. So if you've got buildings that block direct sunlight coming through the fenestration, then you do not have a daylit zone there. And again, visible transmittance comes into play. So there's a specific equation there to determine whether you've got a daylit, top lit zone within your space. And now we will hand back to Ryan to cover specific application controls.
Well, thank you, Sean. So these are some specific areas that the code calls out for having controls in addition to your general area lighting controls. And so these can either have occupancy sensors or occupant sensing devices or time switch controls. So some of these, as you see in the picture, for display cases and things of that nature, here in a grocery store, you may have janitorial staff that are going to be cleaning the building beyond the normal business hours, and so you want to be able to control your general overhead lighting independent from the display cases. Code also calls out for sleeping units, so this is in commercial buildings and commercial occupancies that would be non-permanent residences, so hotels, motels, requiring occupant sensing devices, or in lieu of that, you can use key card controlled switches and receptacles for that. And also noting patient care space, where patient care is directly provided, also has an exception to this. Another area is lighting for non-visual applications, food warming, very similar to the display cases, where food is not likely to be present during the same hours as the restaurant is open and occupied with people, as well as for plants. So as we see more grow operations, again, wanting to make sure that the plant needs is separate from the occupancy needs of these spaces. So moving from the inside to the outside, exterior lighting controls, the code calls for exterior lighting controls differently depending on where they are. Exterior lighting is broken into two categories. One is general exterior lighting, and the second is decorative lighting. Decorative in this case being facade and landscape lighting. And so there are 4 criteria, 3 of them apply to each, and as you'll note, decorative lighting has one set of criteria, and general area has a separate criteria for lighting setback. Both of them do require daylight shutoffs as well as time switch controls. So as far as this goes for exterior, as noted, we do have daylight shutoff that's required no matter where that is. For exterior lighting, whether that's general exterior lighting or facade and landscape lighting. And what we're trying to prevent here is what you see in that picture there, where here you've got exterior lighting on in the middle of the day. And in particular, LED fixtures are sensitive to temperatures. And so if we can prevent LEDs from operating in the middle of the day while the sun is shining, that's going to greatly increase their lifespan. So that can be very helpful there. As far as shutting off or setback, this depends on what type of lighting that you're dealing with. Decorative lighting, so here we're talking again facades and landscapes, has to be shut off within 1 hour of the business closing and cannot turn on more than 1 hour before the business opening hours. So this allows for some indication and sight. So as people arrive, shortly before business opens and closes, you still have your lit facade and landscape. For your general lighting for exterior, we have to reduce the lighting power by at least 30%. So this could be done as noted by switching or dimming. And one way that we have seen this done is fixtures closer to the building would remain lit, and the ones further away we might see turned off. This can be done one of 3 ways. The first 2 are time-based, and the third is occupancy-based. So either from midnight to 6 a.m. or that similar 1 hour within 1 hour of close or opening of business. So if you choose to do the 1 hour of open and close of business, that could allow you to use the same time switch controls for your general lighting as your decorative lighting, because those would be overlapping times then. So time switch controls do have to have the same requirements as the interior. Again, of particular note there is that 10 hours of memory. So in the event of loss of power, you don't lose your program for at least 10 hours. So that doesn't necessarily preclude mechanical time clocks, but we'll definitely see this going more towards digital time switch controls in the future. So as far as lighting power allowances, here we've seen a dramatic change for track lighting. For the 2018 version, the default has dropped from 30 watts per linear foot down to 8 watts per linear foot, or the connected load, whichever is higher. Again, the code is recognizing the industry's transition towards LEDs and trying to fit 30 watts on every single foot of track lighting was becoming more difficult just from a practical standpoint. So the code is recognizing this. We will call out this is one difference between the IECC and ASHRAE 90.1. 90.1 still has the 30 watts per linear foot for their design. The National Electric Code calls out even higher at 75 watts per foot. So just being aware that those limits are out there. So there are still the same 2 methods to calculate this, either the building area method or the space by space. Building area method is a much simpler calculation to perform as compared to the space by space method. However, one benefit of the space by space method is that you can trade off between spaces. So one example that we had come through was there was a restaurant next to a hair salon, and the building area method had those as two separate categories. The restaurant needed some additional lighting power capacity, and so by using the space by space method, they were able to trade some of the, use more efficient lighting practices for the salon to free up additional power that could be used by the restaurant. So here noting that the building area method, we've seen a slight improvement from the 2015 to the 2018, about just over a 10% change for most spaces. The last three we call out here because for libraries, they saw the most dramatic reduction, dropping by over a third from 2015 to 2018. Dormitories, we saw an increase between the two code cycles. And the Performing Arts Center, we call out here because that is the highest one on the table. When Illinois first adopted the energy code, offices and universities had a limit of about 1.5. And so you can see now even the highest value on the table is under 1.2. So the code and the industry in general has seen a dramatic improvement in lighting technologies and practices. So one way this might appear is for a library here, fairly sizable at 100,000 square feet, moving just from a code compliant 2015 building to a code compliant 2018 building, that would be a reduction of 41,000 watts they'd see, which is 12 tons of cooling that would no longer need to have been purchased, installed, and operated. So this is a very dramatic improvement with time. So as far as exterior lighting, this is a little different in that there's multiple zones depending on where you are. So we don't just have the spaces to look at, but we have to consider where we are. Most projects will not be in zones 1 or 4. Zone 1 is for like state and national parks and similar spaces. Zone 4 is only for high commercial activity in a major metropolitan area as deemed by the local zoning commission. And so for the state of Illinois, Zone 4 would only be found within the confines of the city of Chicago, and they're predominantly only for things such as like State Street or Michigan Avenue. So the vast majority of projects you're looking at are Zone 2 and Zone 3. Zone 2 and the difference between those two is generally, do I have residential nearby? Zone 3, as you can see from that picture, that looks like a hotel or a large office building in kind of a park, so there's not really any residential around that. Zone 2 is neighborhood commercial district, so you're going to have residential nearby. Obviously, the more major, the more activity you have, the higher the allowance. So Zone 1 is the most restrictive and Zone 4 is the most liberal as far as the budget goes. So as far as what this might look like, here's a sampling of one of the tables out of the book. We've seen a dramatic improvement in exterior lighting, and this has predominantly been from the shift from traditional metal halide and high pressure sodium sources over to LEDs. we anticipate that the interior will continue to see a shift similar to this as we move from fluorescent to LED as well. So with that, I'm going to turn it back over to Sean as we get into our commissioning section.
All right, thank you, Ryan. So first thing we're going to cover is the functional testing requirements in the code for lighting controls. Functional testing must be completed before the final inspection. A registered design professional is to provide evidence of that testing for all the different controls installed for the lighting system, so occupancy sensor controls, time switches, and daylight responsive controls. Realizing that a lot of times building inspectors will be out to the building and this commissioning will not be completed during the inspector's final inspection. One of the requirements stipulated in the code is that manuals and a commissioning report should be provided to the owner within 90 days of receipt of their certificate of occupancy. And so code officials are expected to just let the building owner know that they are going to see that report for commissioning. So that the owner knows that that report is coming to them. As far as what is required for testing, for occupancy sensors, certification that those sensors are located and aimed per the manufacturer's recommendation, so you don't have a sensor in an office that's being triggered by someone walking by in the hallway, as an example. We've actually seen this in a couple of spaces that have transparent separators between a hallway and the space. Sometimes those sensors will trigger from someone walking past the window. We've also seen in restrooms and spaces with mirrors in them that someone walking past in the hallway, their reflection in the mirror will trigger the sensor. So that's why that requirement is in there for commissioning, making sure that those sensors are only triggered when someone is entering the space that the sensor is covering. Testing for each space geometry, sensor combination should include 10% of each combination. So if you've got a number of cookie cutter classrooms or office spaces or some other space that they all have the same orientation, the same general space geometry, lighting is set up the same way, only 10% of those would have to be checked. But if you've got a mirror copy of a room, that's a different geometry, or if you've got a different lighting pattern in that space, those would have to be tested independently. And then verifying the status indicators, time delays, and all that are working properly, and there's no false tripping due to HVAC operation or other equipment within the space. So that, again, that sensor is only triggering based on occupants being in that area. For time switch controls, you have to verify that the weekend, weekday, and holiday schedules are all programmed properly and working properly. Documentation of programming should include schedules, setup, documentation, and preferences for the programming in that time switch. This can be just a report. I think a lot of digital time clocks can have a printout, especially if they're tied to a BAS system. Those settings can be printed out in a form that documents those settings, and that qualifies for verification of the controls. And again, point number 3 there, verifying date and time, installation and operation of the battery backup, that the override works. Again, just testing and verifying in the space that if I hit this manual override switch, it's going to turn the lights back on. The schedule is going to turn these lights off, and that it's controlling the lights that are supposed to be connected to that particular sensor. I've been in a building that had time switch controls installed that were actually wired up backwards, where an off command turned the lights on and on command turned the lights off. So again, commissioning, very important to make sure that those things are working properly. For daylight responsive controls, very similar requirements to the occupant sensors. Again, you're verifying control devices are properly located, calibrated, and that set points and thresholds are set properly so the lights dim appropriately with incoming daylight. And again, there is a requirement that spaces with similar orientations, similar design, if they're cookie cutter copies of each other, you only have to test so many of them. But again, if you've got different orientations, an overhang over a window or something that makes that space have a different daylighting inflow, that sensor is going to have to be commissioned independently. And calibration equipment should be readily accessible only to authorized personnel. This was stated earlier in the daylight control section. It's repeated here for the commissioning section. So if you've got some kind of wireless sensor for calibrating those lights, it can be locked away in a closet, cabinet, accessible only to building maintenance staff. They have to get it out, use it in the space, verify within the space that that lighting is working properly, and then they can lock that calibration device up again. Moving on, what we're going to look at here is one of the efficiency options. If you're following the prescriptive path in the energy code, there are the efficiency packages that are required addition to further reduce building energy consumption. This one ties in well with the daylighting exception, where if you can reduce your daylighting connected power in your daylit zones, very often you're going to also have reduced your wattage enough to qualify for the reduced lighting power efficiency package. So here, it's noting that to comply with this section, total connected power should be reduced by 10%. So 90% of your total lighting power allowance per the lighting connected power section. And if you remember our earlier example of the 200,000 square foot office with 50,000 square feet of daylit zone, you only required a 10% reduction in lighting connected power in order to not have to install and commission all those daylighting sensors. So this is a good way to get two birds with one stone with the code, and it saves your maintenance people a lot of time maintaining those daylight sensors. It saves on commissioning costs, saves on installed equipment costs. This is a good all-around combination for your lighting controls. The next section we're going to cover in that efficiency package option is enhanced digital lighting controls. This is not one that we see used very often, but it is kind of helpful for spaces that are going to have modular setups to them. Enhanced digital lighting controls are going to have these specific requirements that are going to allow for continuous dimming of lighting. Individual lighting is going to be individually addressed, so it can be reconfigured depending on how your space changes over time. You can reconfigure those lights to control in different groups. Say you've got a cubicle space or something, and you want lights to control individually over cubicles. If those cubicles move somewhere down the road, an enhanced digital lighting control system is going to allow you to reassign those lights appropriately to the new floor layout. However, this does have some additional commissioning requirements, excuse me, and some additional complexity to the system. So there are some additional costs, but again, if you've got a modular type space, this could be a beneficial option for complying with the code. Moving on to luminaire level lighting controls, this is a growing trend that we're seeing. Each individual fixture is going to have daylight and occupancy sensing controls wired directly into the fixture itself. So again, this is going to have some increased front-end work for commissioning, so you've got a lot more sensors to look at. But again, modular spaces are a good application for this. You save some upfront costs with wireless sensors and things on the installed cost for wiring sensors into the building. So there are some benefits to this, but again, some additional commissioning, some additional maintenance down the road as these sensors fail over time. So there are some considerations there. As far as specific requirements within the code, you can see called out here, luminaire level lighting controls have 3 specific sections they have to comply with. So occupancy control section, the specific application control section, and the manual control of lighting, so the manual overrides. Luminaire level lighting controls should be independently capable of these things, monitoring occupancy to brighten or dim lighting, also for daylighting controls, and configuration and reconfiguration of spaces and performance parameters. So again, if you've got a modular space or things changing over time, these provide the flexibility within that system to reconfigure as needed. So now we'll move on to questions. I'll let Ryan take back over as he's looking at the question screen.
All right, so we have several questions here. First of all, looking at understanding there may be some people that are viewing this webinar in a group setting. So when we provide the initial certificate along with the request for AIA or ICC numbers, you can provide those for the group that is in the space viewing it with you. So yes, there is a way to handle that. As far as a question here regarding if we provide consultation for architects and review, recommendation and preparation of construction documents to be submitted, we are here to provide technical assistance for projects here in the state of Illinois. It does not necessarily mean that the firm is located here, just that the project is. So we've helped people all the way from Vermont to Colorado so far. So. Yes, if you do run into, we're here to provide technical assistance, design professionals, building owners, occupants, code officials. So yes, we're here to serve all the people in the state of Illinois. Another one here is a question regarding compliance. If a project can comply with both ASHRAE 90.1 and the Illinois Energy Conservation Code, or does it have to be one or the other? Code compliance has to be shown via one method. However, code compliance is a minimum standard. So there's nothing that precludes a project. If a project wants to comply with the provisions of both the IECC and 90.1, that's perfectly acceptable. When we're talking in a longer, one of the top 40 presentations that we do, we actually like to call out some of the provisions in 90.1, one of which we find to be very beneficial, and that is the utility monitoring provisions of ASHRAE 90.1, which two of the categories that it requires is monitoring of exterior lighting as well as monitoring of interior lighting. So those can be very beneficial for troubleshooting. So it may be helpful to pick up some and use some of the provisions from the other code that you're not necessarily using to show compliance for a particular project. So next one here is looking at bi-level lighting controls for stairways. The code does have an exception where lighting controls are not required for stairways. And there are some, there may be some life safety potential issues if you do have lighting controls in stairwells. However, bi-level lighting controls can be very beneficial to provide both energy savings and perhaps maintenance savings, while at the same time still providing for adequate life safety to make sure that people can see when they do use the stairwell. Next here we've got a question regarding perimeter offices, where an office only has a 4x5 window, so 20 square feet. That would actually be below the threshold to qualify as a day-lit zone. If I recall, the requirement is 24 square feet of fenestration area in order to qualify as a day-lit zone or a side-lit day-lit zone. So yes, if your office only has a 4 by 5 foot window, you would be below that threshold, so you would not have a daylight zone in that office. So therefore, no daylight harvesting controls would be required for that. Next, we've got some questions regarding 24/7 operations. We've run into this. This may be for manufacturing, may have this, as well as another place that we've run into this frequently has been hotels. You know, business hours of a hotel frequently are 24/7, and so you wouldn't necessarily have that 1 hour before and 1 hour after opening. So those you wouldn't necessarily have the compliance method for that 1 hour before and 1 hour after. However, that may be it may be wise to install the controls so that manufacturers, while they may be a 3-shift 24/7 operation today, in the future that may drop to only a 2-shift a day operation. So then you would have opening and closing hours for that. So that's just something to be aware of, where your operation today may not be the same as in the future. I believe there's also an exception in there for lighting that is supposed to be or is intended for continuous operation. So that's your typically your security and egress lighting. So you would not necessarily need controls for those as well. So I have one here about commissioning of lighting systems. Question is if a PE is the only approved registered design professional, and what to do regarding a certified commissioning agent. Registered design professional, the code calls out the language for that being typically it's only just the architect or the engineer. However, the documentation for the commissioning, the code has, this is C405.2.3 prior to passing the final inspection, the registered design professional shall provide evidence that the lighting control systems have been tested to ensure that it has been adjusted and programmed and in proper working order. So that doesn't necessarily mean the engineer or the architect has to have done the commissioning. They only have to provide the evidence of the commissioning. So you could have the commissioning agent go through, do the commissioning, provide that evidence to the design professional, and the design professional then presents that to the code official as part of the documentation package. So we would say it's probably unlikely that the engineer or the architect would actually be the one to do the commissioning. So yes, that probably either would be a certified commissioning agent or the lighting designer if it's the lighting system. So question here regarding a copy of the PowerPoint. Yes, the copy of the PowerPoint along with today's recording will be posted to our website, cdac.org. So you can find that for reference later on after today's webinar. So I think we made it through all the questions we had here. I'll give a few minutes, or we'll give a minute here to see if there's any others out there. But do want to thank everyone for their participation today in today's webinar. Again, we will provide an email here before too long with a participation certificate along with request for participation in our survey, so we can learn how we can do better going into the future, along with AIA and ICC registration numbers, so we can file those appropriately with the organizations to make sure that you get the proper credit for today's webinar. So if that's it, I want to thank everyone again, and have a great day.